The natural logarithm is a fundamental function in mathematics, but its integral isn't immediately obvious. Unlike the power rule, we can't find the antiderivative of ln x through simple inspection. Today, we will unlock this result using a powerful technique called integration by parts. While we know the derivative of ln x is 1x, the integral requires us to work backward. Since ln x can be viewed as the product of 1 and ln x, we can apply the integration by parts formula to solve it systematically. The integration by parts formula is derived from the product rule for derivatives. It allows us to trade a difficult integral for a simpler one by choosing which parts of the expression to differentiate and which to integrate. To integrate ln x, we treat the integrand as a product. We set u equal to ln x because its derivative is a simple algebraic fraction, and we set dv equal to 1 dx, which is very easy to integrate. Now we compute the missing pieces. Differentiating u gives us 2 equals 1 over x dx. Integrating dv equals 1 dx gives us v equals x. We now have all 4 components needed to populate our integration by parts formula. Substituting our terms into the formula, we get x times the natural log of x, minus the integral of x times 1 over x. Notice how the x and 1 over x inside the integral are positioned to simplify beautifully. Inside the integral, the x in the numerator and the x in the denominator cancel out completely. This leaves us with the simplest possible integral, the integral of 1 with respect to x. This is the magic of choosing u as the logarithm. The integral of 1 is simply x. When we subtract this from our first term, we get x ln x minus x. Finally, we add the c, the constant of integration, to represent the entire family of possible antiderivatives. We have successfully found the integral of ln x. It can be written as x times ln x minus x, or more elegantly by factoring out the x. This result is a standard tool in calculus used in many advanced physics and engineering problems. To verify our work, we differentiate the result. Using the product rule on x ln x gives us ln x plus 1. Subtracting the derivative of the second term, which is 1, leaves us with just ln x. Our integration is correct. Let's apply this to a definite integral from 1 to e. We substitute the upper bound e and the lower bound 1 into our antiderivative. Remember that the natural log of e is 1, and the natural log of 1 is 0. The first part simplifies to e minus e, which is 0. The second part simplifies to 0 minus 1, which is negative 1. Subtracting negative 1 gives us a final area of exactly 1. This is a clean, significant result in geometry. What if the argument is more complex, like ln of x squared? We can use logarithm properties to move the exponent to the front, turning it into 2 times the integral of ln x, which we already solved. By distributing the 2, we quickly find the integral without having to perform integration by parts from scratch. Always look for ways to simplify the integrand using log properties before starting your calculus. To remember how to choose u, use the Liate mnemonic. Since logarithmic functions appear first, they are almost always chosen as u when paired with algebraic functions like 1 or x. This ensures the derivative simplifies the expression. In summary, integration by parts is the key to handling ln x. By differentiating the log and integrating the hidden constant 1, we transform a difficult problem into basic subtraction. Always remember your constant of integration. Try this on your own, integrate ln of 2x. Following the same steps, you will find it results in x ln of 2x minus x plus c. Thank you for learning with us today. Generated by Vision Solve AI.